Are you ready to journey back in time, over 12.5 billion years ago, to discover the secrets of galaxy evolution? Buckle up, because we have a fascinating story to share with you. Thanks to the power of the James Webb Space Telescope, the earliest known, Quenched Galaxy has been discovered, giving us new insights into how galaxies live and die across cosmic time. This galaxy, called GS 9209, abruptly stopped forming stars more than 12.5 billion years ago, just a little over a billion years after the Big Bang. But what caused this sudden halt in star formation? Was it an actively feeding black hole? And what can this tell us about how galaxies form and evolve? Join us as we explore the incredible discovery of GS 9209 and unravel the mysteries of galaxy evolution. Hello everyone, welcome back to TUAC, the Universe and Astronomy channel where we bring you the most recent news about the endless and unknown universe, the secrets of astronomy, space news, and NASA updates. Before we begin, please don't forget to subscribe to our channel and click the bell icon, to not miss any of our interesting videos. On galaxy evolution. Galaxy evolution is the study of how galaxies form and change over time. The prevailing theory is that galaxies formed from clouds of gas and dust that collapsed under the force of gravity. As they formed, galaxies also underwent mergers and interactions with other galaxies, leading to the formation of more massive galaxies. One important aspect of galaxy evolution is star formation. Stars are the building blocks of galaxies, and they form from the gas and dust that make up galaxies. As stars form, they produce energy and heavy elements that are eventually recycled into new generations of stars. Another important factor in galaxy evolution is the presence of supermassive black holes at the centers of galaxies. These black holes can have a profound effect on the surrounding gas and stars, and their activity can regulate star formation and the growth of the galaxy itself. By studying galaxies at different points in cosmic history, astronomers can piece together the story of how galaxies have evolved over billions of years. The discovery of quenched galaxies like GS 9209, which have stopped forming stars, provides clues about the mechanisms that halt star formation and ultimately lead to the death of galaxies. Understanding these processes is crucial to unraveling the mysteries of galaxy evolution. On quenching. In astronomy, a quenched galaxy is a type of galaxy that has stopped or significantly reduced its rate of star formation. Quenched galaxies are typically old, with stars that formed early in the galaxy's history, and are often red in color due to the lack of new blue stars. Quenching can occur through a variety of mechanisms, such as the exhaustion of gas that fuels star formation, the merger with another galaxy, or the heating of gas by radiation or shocks. As a result of quenched galaxies tend to have lower levels of gas and dust than star-forming galaxies. Quenched galaxies are an important area of study in astronomy, as understanding the processes that lead to quenching can shed light on the evolution of galaxies over time. For example, the observed correlations between galaxy properties such as color, mass, and morphology suggest that quenching is linked to a galaxy's environment and interactions with other galaxies. On the discovery. Thanks to the James Webb Space Telescope, we now have the privilege of observing galaxies that existed more than 12.5 billion years ago, a little over a billion years after the Big Bang. And among all those galaxies lies the quenched GS 9209, the earliest known galaxy to suddenly stop forming stars. How did this happen? Why did it happen? Well, that's what astrophysicist Adam Carnell and his team are trying to figure out. GS 9209 was first discovered in the early 2000s, but it wasn't until the James Webb Space Telescope in 2021 came along that they could confirm its distance and status as a quenched galaxy. The telescope's sensitivity to infrared light and its location above the Earth's atmosphere allowed for quick and accurate observations, revealing that GS 9209 formed most of its stars in a 200 million year period, shortly after the Big Bang. It was during this time that the galaxy built about 40 billion solar masses worth of stars, making it almost as massive as our very own Milky Way. So how did this quenched galaxy come to be? According to Carnell, it formed from a massive cloud of gas and dust collapsing and igniting stars all at once, a process known as monolithic collapse. This mode of galaxy formation was once thought to be the primary way that most galaxies were formed, but it has since been replaced by the idea that large galaxies form from the slow merging of many smaller ones. But what caused the sudden halt in star formation? The Webb telescope observations detected extra emission of infrared light associated with an actively feeding black hole. This black hole is thought to be up to 1 billion times the mass of the Sun, and it appears that its energy output may have heated up nearby gas, stopping it from forming new stars. But more observations are needed to confirm this hypothesis and to learn more about the fate of GS 9209. On its significance. The discovery of the earliest known quenched galaxy, GS 9209, sheds light on the evolution of galaxies across cosmic time. Quenched galaxies are galaxies that have stopped forming new stars, and they provide important clues about the mechanisms that drive galaxy evolution. Understanding the formation and evolution of galaxies is a fundamental goal of astronomy, as galaxies are the building blocks of the universe. GS 9209, which stopped forming stars more than 12.5 billion years ago, is an important discovery because it is a rare example of a galaxy that quenched when the universe was still very young. By studying such galaxies, astronomers hope to gain insights into how and when quenching occurred on a larger scale throughout cosmic history. The study of GS 9209 also provides new evidence about how galaxies form. The galaxy appears to have formed from a massive cloud of gas and dust collapsing and igniting stars all at once, a process known as monolithic collapse. This mode of galaxy formation was previously thought to be the most common, but it has fallen out of favor in recent years in favor of the idea that large galaxies form from the slow merging of many smaller ones. The discovery of GS 9209 provides strong evidence that monolithic collapse did indeed happen in at least some galaxies. Today, we explored the discovery of the earliest known quenched galaxy, GS 9209, and unraveled the mysteries of galaxy evolution. Through the use of the James Webb Space Telescope, we were able to get a glimpse of a galaxy that existed over 12.5 billion years ago, shortly after the Big Bang. We learned that quenched galaxies, like GS 9209, are important in understanding how galaxies evolve over time and how their star formation can suddenly halt. The discovery of GS 9209 and the potential for an actively feeding black hole stopping its star formation has shed new light on how galaxies live and die across cosmic time. As we continue to study the universe, let us remember that there is still so much more to learn and discover. Thanks for watching, and don't forget to like, comment, and subscribe for more fun and informative videos about the universe.